Guys, so today we are solving this problem of number of ways to split array. So you are given a zero indexed integer array nums of length n. Nums contains a valid split at index I if the following are true. So basically what is happening is we are given an integer array. So at I index, okay, there could be any index I. So on the left side of that index, including that value, the sum on the left side should be greater than the sum on the right side. So if we find such point, then that point would be one valid split. So we have to find all such splits. So let's take the example of this case. So this is our nums array. Okay, so if we start from this point, let's say we are starting I equal to 0. Okay, so at I equal to 0, this is very first element, right? So what would be the right side sum of all of them is? That would be basically the sum of all these guys, right? 4 minus 8 and 7, right? So what is the sum of it? Sum is it is 3, right? 8 minus 8 plus 7, it would be minus 1 and 4, so it would be 3 here, but at this point it is 10, right? Include that number at I. So basically this is a point, valid point, split point, because the left sum, okay, we can say here left sum. Okay, so what is the left sum here? Left sum is 10 here at I equal to 0. Left sum is 10 and right sum, let's say I'm calling it right sum R sum. So what is the R sum here? R sum here is minus 8 plus 7, which is minus 1 plus 4. So it is 3. So here we can say that left sum is basically greater than the right sums. So we found one valid point. Okay, now we'll come to this, right? We are coming to I equal to 1. So what is the left sum now? So at I equal to 1, the left sum would be 14, 10 plus 4, right? So left sum would become now 14, and what would be the right sum? It would be minus 8 and 7, so it would be minus 1. So again we found a point where left sum is greater than the right sum. So we got one more, so we will increase count by 1. Now we'll come to this point, I equal to 2. So what would be the left sum here? Left sum would be 10 plus 4 minus 8, right? So this would be 6 this time. So left sum is now becoming 6, and what is the right sum? Right sum is 7 only. So this time left sum is not greater than right sum, so this is not a valid point. And anyway we will stop on the second last because it is given in the question. You can see here I would be starting from 0 till the second last element, because we need to have at least one element on the right side of any I index. So this is we have to find the total number of such points which are the valid split point. So this is what we have to do. Now we will decide that how to do that. So one approach is like first of all there could be a prefix sum approach, right? We can get the left prefix as well as the right prefix, but in that case we need the extra arrays, right? So we want to do it in the constant time. So how we would be doing? We can do it with the two variables. Let's say again we will keep two variables, left sum and right sum. So let me do that. So I am taking one variable called left sum, which will get the sum of the left side, and I would be having one as the right sum. Okay, so this is my right sum. Initially both of them are, this one is 0, but in this right sum what I will do is I will get the sum of all the numbers in this array. Okay, why? Because anyway in right sum initially we are starting from 0, right? So initially I am keeping everything the sum of all these elements. So what would be the sum here? 10 plus 4 is 14 and minus 1, so it is 13. So initially in one go we can get the sum of all the elements into the right sum variable. So now it is 13 and left sum is 0, right? Then we will start our traversing from here, right? we will start from here. So I equal to 0. Okay, so whenever we are getting whenever we are traversing initially, let's say with I equal to 0 we starting, so what we have to do is basically we will use this thing, that whenever we want to get the left sum, what we can do is left sum basically it would be equal to whatever value, left sum equal to plus of whatever value we are getting, so nums I here. Okay, so it would be like this, nums I, because this would give us the left side sum, correct? Like in this case when we are starting here, our left side sum would be left sum plus nums I, so which is 10. So initially it would become 10 when we are at here. Okay, so this would be 10, and what would be the right sum in that case? So for right sum, what we will do, for right sum we will decrease whatever element is there. Okay, so for this we will use this minus 1 and with the same element nums I at the index I. So in this case what will happen is it will give us the right sum, because we already started right sum with the sum of all the elements. So that is why we are making right sum equal to right sum minus nums I. So now when our left sum is 10, our right sum would our right sum would be, we will decrease this value here. So 13 minus 10, it would become 3, right? So our point, we have found one valid point because our left sum is greater than this guy 3, so we got 1, right? Now what we will do is our I would become 1, so we are coming here. So what will happen is at I equal to 1, left sum equal to, see here, left sum equal to left sum plus nums I, so it would become now 10 plus 4, so it would become now 14, right? And this sum, right sum would be right sum minus nums I, so it would become 3, right now it is 3, so 3 minus 4, so this would become now minus 1, correct? 3 minus 4 is minus 1. So now we can see here again our 14 is greater than minus 1, so we got one more valid point. Now our I would come to here 2, right? So what would be our left sum now? So it would be 14 plus minus 8, which would become 6, right? And what would be the right sum? Right sum would be our this guy minus 1, and this is minus 1 minus, so it would become plus, right? So it would become 9, correct? So right sum would become, we are making it minus, so it would become 9. So see here, this is not a valid point, right? Because left sum is smaller than the right sum, correct? So in this case we can say that okay, our yeah, so here it would be basically 7. Okay, this right sum would be 7. Yeah, so now this is not a valid point, so anyway we found 2 valid points here, so this 2 should be our answer. So in this way what we are doing is we are going in one pass, we calculated the sum initially for all the elements, then we are getting one more pass, so we are not using any extra space, only with the 2 variables we are able to solve this problem. So thank you for watching this video. Let me show you my corresponding code as well, so you guys can see here I have taken these 2 variables, left sum, right sum, and this answer variable. I am taking here long because we are getting the sum of all the elements, so this can go very huge. So to save ourselves from any overflow, I am using here long. Then what I am doing, initially see here I am taking the sum of all the elements in right sum variable, then I am traversing from I equal to 0 till I less than n minus 1, because we are stopping in the second last element for our I. Then see here I am getting the left sum with the new value whatever nums I, we are adding it, and in right sum we are decreasing it, because in right sum we already get all the sum of the element. So this will give us the left sum, this will give the right side sum. So whenever we are getting this point, when left sum is greater than or equal to right sum, we are increasing answer by 1, and I am returning it. So let me execute this code. So yeah, I already submitted, but let me submit again in front of you. Yeah, so it is 100% faster. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.